Okay, hi guys. I'm on week 8, task 6, and we just went through the PowerPoint of doing double replacement and combustions, and then you had a worksheet that had 11 of them on it. So I'm going to go through, you have the answer key too, so I'm going to go through and do a few so you guys can see me do a couple, and then hopefully you'll get it from there. So I don't know. Last time I did 3, 6, 9, so I'll just do those again. Doesn't matter. So number 3, potassium oxide plus calcium chlorate yields what? Well, I'm going to have to write the second line down here because it's a lot of words. So when I look at this, it's a double replacement, right? This is A, B, C, D. So I know that potassium's a metal, so I'll circle that. And I know that calcium's a metal, so I'll circle that. And they're just going to do the square dancing like I told you learned in gym class in grade 6. So square dancing, they're just going to switch partners. These metals are just going to switch. So I'm going to get potassium. He went with chlorate. Plus calcium went with oxide. All right, so that's what it looks like. Now let's have some scrap work down here, and we're going to write out this equation. So here's our scrap down the bottom. So potassium oxide, well, we don't know what that looks like. So get your periodic table, and you'll know potassium is a +1. Oxide, O minus 2, crisscross, K2O, that's potassium oxide. So let's write that here, K2O plus calcium chlorate. Well, calcium, Ca is a +2. Chlorate, you need to look that up on your sheet here. When you look at your polyatomic sheet, you can see chlorate right here, ClO3 minus 1. ClO3 minus 1, you crisscross, what do you get? Ca, open a bracket, ClO3, close the bracket, 2. Calcium chlorate, Ca, open the bracket, ClO3, close the bracket, 2. Yields potassium chlorate. Well, we've already looked here. Potassium's a +1. We know what chlorate is. ClO3 minus 1. KClO3, that's potassium chlorate. KClO3 plus, we get calcium oxide. Well, calcium we knew is a +2. Oxide we know is a -2. Crisscross, Ca2O2, which gets reduced to CaO. CaO. So there's our formula written out. Now we have to balance it. You can go back and forth, like you can write each side, but now I've done enough of them with you. We can just do it back and forth in our head, so you do whatever method you'd like. So I see I'm going to start here with potassium. There's 2 on this side and 1 on this side, so I'm going to make this side a 2. So my potassiums are good. I've got 1 oxygen here, 1 oxygen here by itself. That's good. I've got a calcium here and a calcium here. That's good. And ClO3s, I've got 2 of them here and 2 of them here. We're balanced. We're done. Okay, so number 3, I have this formula. So that was on the worksheet. Let's do number 6, because, I don't know, I've been doing 3, 6, 9 lately, so that's what I'll do again. So let's do number 6. I don't pre-look at them, I just do them with you guys, whatever. So we've got lead to oxide, iodide, plus strontium carbonate. All right, so lead 2 is the metal, strontium's the metal. They're going to square dance. Okay, let's see, what would we write out? Well, lead 2 is going to go with carbonate. And strontium is going to go with iodide. So pretend that's all written out nicely on one line because I can't fit it, but there you go. So let's do the scrap and we'll figure out what these look like. Lead 2 iodide. Well, we don't have to look that up. Pb plus 2. It told us it was lead 2, so that saves us some time. Iodide. Look him up. Iodide right there. He's a -1. I -1. Crisscross. What do we get? Pbi2. That's here. Pbi2. That's lead 2 iodide. I'm going to add strontium carbonate. Well, let's look up strontium. It's not one that's commonly used. Right here, Sr plus 2. And we better look up carbonate on our polyatomics. You can see it right here at the top. Carbonate, CO3 -2. Crisscross. I get Sr2, open a bracket, CO3, close the bracket 2. But because there's 2 of each, I have to reduce it to SrCO3. Again, you can put in brackets, but I don't really like them unless you need them. In grade 12 chemistry, that would be a bit frowned upon. So let's just go SrCO3. For strontium carbonate, we're going to yield to lead 2 carbonate. Well, let's see what that looks like. Lead 2 is Pb2. Carbonate, CO3 -2. We already looked that guy up. Pb2, open the bracket, CO3 bracket 2. But again, we've got 2 of each. We've got to reduce that to PbCO3. PbCO3. Plus strontium iodide. Well, strontium is Sr plus 2. Iodide is -1. Sri2. Sri2. I'll put the blanks in for balancing. There we go. Let's go back and forth. 1 lead, 1 lead. 2 iodide, 2 iodide. 1 strontium, 1 strontium. 1 CO3, 1 CO3. Ooh, got lucky. Already balanced. That was nice. Okay, so that was 2 double replacements. So now I'll do a couple, I'll do 2 more because I'll do 2 combustions. That was 2 double replacements, so I'll do 2 ones that are combustion examples. So let's look at, ooh, let's do this one. This one's good. Calcium hydroxide plus phosphoric acid yields what? I've got hydroxide, which is a base, an acid. So I've got an acid and a base. This is going to be a neutralization. Neutralization. Acid and a base. So calcium hydroxide, we can figure out what that is. Okay, let's look down here at the scrap. Calcium hydroxide, calcium, look him up. He's a Ca plus 2. Hydroxide is on your polyatomic sheet. OH -1. Crisscross, we get Ca, open the bracket, OH, close the bracket 2. So that's calcium hydroxide. Ooh, phosphoric acid. We see an ick. So let's get our acid cheat sheet that you might have wished was over, but it's not. It's an ick. So if we change the ick back to what it originally was, it would become an 8. So phosphate. What is always, always, always in an acid? Hydrogen. So really, you could also call for phosphoric acid hydrogen phosphate. And so when I look at this, I need to say hydrogen is a H plus 1. Now I have to look up, what does phosphate look like? PO4 minus 3. I do a crisscross, I get an H3PO4. Okay, so that's phosphoric acid, or we can call it hydrogen phosphate. It doesn't matter. H3PO4. And we knew here, calcium hydroxide is CaOH2. All right, so what are we going to yield on this side? Let's change this name to hydrogen phosphate. So this is the metal and this is a metal. So it's the same situation here. We've got a neutralization, but the calcium is going to go with the phosphate and the hydrogen is going to go with the hydroxide. So I'm going to write those out here. Calcium is going to go with phosphate plus hydrogen is going to go with hydroxide. All right, that's good. So now we just have to finish writing this out. I'm going to move this down a row just a sec. CaOH2 plus H3PO4. I'm just going to scratch those because they're kind of in line with my words. So just ignore those for a sec. Yields calcium phosphate. Well, what that look like? Ca plus 2. What's phosphate? PO4 minus 3. So what do I get? Ca3, open the bracket. PO4, close the bracket 2. So I get calcium phosphate. Ca3, PO4, bracket 2. Plus hydrogen hydroxide. What does that look like? Hydrogen plus 1. Hydroxide's a minus 1. HOH, which is also H2O. So water is hydrogen hydroxide. I like to write it HOH because then you can see your polyatomics and keep them together. All right, now we got to balance this. I'll put some blanks in here for some numbers. Okay, 1 calcium on this side, 3 on this side. Let's put a 3 out here. Now I've got my calciums, good. I've got 6 OHs on this side. I'm going to put a 6 here. That gives me 6 OHs. I got 3 H's here. I've got 6 H's here. So I've got to put a 2 here. 2 PO4s, 2 PO4s, and I'm balanced. I know I do that pretty fast, but you guys should be catching on to that a little bit at this point. Okay, so let me see. Those are all, that was neutralization, so that was a good one. Let me find a combustion. They don't really have any combustions on this sheet, do they? No, you guys got lucky. This whole sheet is just double replacement. Here's a couple. I guess they didn't write out the names for them, so we'll do a couple of these. So I'm going to do number 12, C2H6 plus O2 yields what? This is a combustion. Okay, C2H6 yields plus oxygen yields what? Well, remember the little chart I told you guys to write down from your notes? If you have a carbon, your product will be CO2. These are rules. We have a carbon in our reactant, and we have a hydrogen in our reactant. Well, if you have a hydrogen, you get water. That's it. We had a carbon, we had a hydrogen. You're always reacting with oxygen in a combustion. Boom. So now you got to balance it. Always leave the O2 to the end. So let's go back and forth here. This one's a little tricky, so I'll write them out for you. Carbon, hydrogen, oxygen, carbon, hydrogen, oxygen, carbon. On this side, I've got 2. I've got 6. And here I've got 2. Here I've got 1. Oxygens, I have 3. Hydrogens, I have 2. All right, let's see. 2 carbons here. Let's put a 2 out front here. That gives us 2. And that gives us 4, 5. Hydrogens over here are 6. Hydrogens over here are 2. So let's make that a 3. 3 times 2 is 6. And I have 3. I have 4 here, oxygens, 5, 6, 7. So I have 7 oxygens here, and I have 2 over here. What do I really want to put in this blank? I really want to put 3.5. If I got to put 3.5, 2 times 3.5 is 7. I am balanced right now. But I can't leave a 3.5. I have to multiply everything by 2. And this guy has like a unseen 1 in it. So when I times every blank by 2 to get rid of this 0.5, we're balanced. So 1 times 2 is 2. 2 times 3.5 is 7. 2 times 2 is 4. 2 times 3 is 6. So when you add it all up, you can see carbons I have 4. Hydrogens I have 12. Oxygens I have 14. And on this side, carbons I have 4. Hydrogens I have 12. And here I've got 2 times 4 is 8. Plus 6. 14. So I am balanced. Okay, so that's a combustion. And then I'll do one more combustion. I'll do I'll do number 16. HNS plus O2. HNS. Well, let's go back to our cheat sheet. If we have an H in there, we get H2O. We have an N in there, we get N2, which is by himself. And we had an S in there, we get SO2. That's what we get. When you know what the reactants are and it's in a combustion, you use that cheat sheet and you end up getting all of these. So now we just got to balance it. I have an H, I have an N, I have an S, I have an O. Here I've got an H, an N, an S, an O. Let's see. Here I've got 1, N's are 1, sulfurs are 1, oxygens are 2. Here I've got 2 hydrogen, 1, 2, 3 oxygen, 2 nitrogen, and 1 sulfur. So hydrogens, I've got 2 here and 1 here. I better put a 2 here. That changes everybody here to 2. These guys are good. These guys are good. Sulfur. I've got 1 on this side and 2 on this side, so I better put a 2 here. That changes my sulfur to 2. Also changes my oxygen to 2 times 2 is 4, plus 1 is 5. Now this O2, if I put a 2.5 here, I'd be balanced. 2 times 2.5 is 5. This would be awesome. Everything's balanced. I'm not allowed to put a 2.5 there, but I'm allowed to put it there temporarily and then times everybody by 2. These guys, if you have nothing out in front, then they're a 1. So I get to times it all by 2. So 2 times 2 in this blank is 4. 2 times 2.5 is 5. 2 times 1 is 2. 2 times 1 is 2. And 2 times 2 is 4. If you rechange it all, you'll be all the way balanced out. So this guy is done. Okay, so that's it for this week. That was the end of my videos, and hopefully you guys understand. Email me if you want a one-on-one. Thanks, bye-bye.